Welcome to Understand the Math. In this video, I'm going to teach you what a one-to-one function is, and then I'll teach you all about the horizontal line test and how you can use it to determine if a function is one-to-one. At the end of the video, I'll show you how to restrict the domain of a function that is not one-to-one so that it is one-to-one. Let's get started. A function is one-to-one if each output value is associated with one input value. Let's look at the graph below so that you can better understand this. On the left, I have a function that is one-to-one, and that function is f of x is equal to x. It's just a linear function. This function is one-to-one because for each input, there is just one output value. On the right, I have a function that is not one-to-one. This function is just the function f of x is equal to x squared, and it's a quadratic function. With this function, we have this input and this input, and both of those inputs have the same y value, which is this value right here. So we have two inputs that have the same output value. And because we have more than one input associated with one output, our function is not one-to-one. Let's now look at this from an algebraic standpoint. Algebraically, when a function is one-to-one, we say that f of x1 is not equal to f of x2. That means the two output values are not the same whenever the two input values are not the same. Let me show you on this diagram what this really means. Our function on the left is f of x is equal to x, and we saw up above that that is a one-to-one function. So what happens is when our x value is equal to -1, our y value or f of x value is -1. Likewise, if it's 0, it maps to 0, and then if x is 1, f of x is equal to 1. So notice that each individual x value maps to a different y value. Now let's look at our function that is not one-to-one. That function is our f of x is equal to x squared. For this function, notice that we have the point 1 and -1 for x. That's our input value. Both of those points map to the same f of x value, which is 1. So we have two inputs mapping to one output. And because of that, our function is not one-to-one. Before we go on to talk about the horizontal line test, I want to tell you one more thing. I want you to know that if a function is one-to-one, it has an inverse. So often we're working with functions and we want to see if it has an inverse. One way to determine if it has an inverse is to see if it's a one-to-one function. If it is a one-to-one function, then we're going to know that it has an inverse. Let's now talk about the horizontal line test. The horizontal line test is just a graphical method used to determine if a function is one-to-one. It's not very hard to learn. Here's what you have to do. To use the horizontal line test to determine if a function is one-to-one, you first need to graph the function, and then you're going to draw horizontal lines on the graph. And then you're going to check and see if each horizontal line intersects the graph only once. If it intersects the graph only once, then it is one-to-one. But if it intersects the graph more than once, then you're going to know that the function is not one-to-one. Let's see how this works in the same functions that we looked at on the previous page. Our function on the left is our f of x is equal to x. To determine if it's one-to-one, I know we already know that it is, but let's use the horizontal line test to see. What we're going to do is we are going to take a horizontal line and we're going to draw it on the graph. So that's just like this. And we'll do a couple of these. We can do one up here and we can do one up here. And then for each line, let's make a circle where it intersects the graph. We have a circle here, and then we have one here, and we have one here. So notice that each of the red lines intersects our graph only once. And that tells us that our function then is one-to-one. Let's look now at the graph on the right. This is our f of x is equal to x squared. And let's go ahead and let's draw our horizontal lines. I'm actually going to do one right down here at the vertex. This line intersects our graph once. Now let's draw another line. We can draw one here, for instance. And then let's see where that intersects the graph. So notice it intersects the graph here and it intersects the graph here. This line intersects the graph more than once. And because of this, we can say that our function is not a one-to-one function. Sometimes notice with a graph that you have to draw more than one horizontal line. Notice in this problem that our first line intersected the graph only once, but our second line that we drew intersected it twice. So just be aware that you have to sometimes draw more than one horizontal line to determine if the function is one-to-one or not. The last topic that we're going to talk about is how to restrict the domain of a function to make it one-to-one. Functions that are not one-to-one can be made one-to-one by restricting their domain. We're going to use our same function down here, our f of x is equal to x squared, which we know is not a one-to-one function. Well, let's say we're working with this function when we actually want it to be a one-to-one function. So what we have to do is restrict the domain. When we drew our horizontal line to this function, it intersected our graph at 2 points. So in order to make this function one-to-one, we just have to split the graph and take only part of it. And we're going to take the part where the horizontal line only intersects the graph once. There's actually 2 choices for this graph. I'm going to choose the one that's positive, so I'm going to choose this portion right here. So if we say that x is greater than or equal to 0, we're only going to end up drawing the right portion of that function. And notice that the horizontal line only intersects that green portion once. So we can say that our function f of x is equal to x squared with the restriction that x is greater than or equal to 0 is a one-to-one function. And that's really nice. So that way we can work with functions that aren't one-to-one and make them one-to-one by just restricting their domain. You may find when you study calculus that you're going to come across functions where you need them to be one-to-one, and now you know how to do it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.